Hello and welcome to Matrices. So in today's lesson we're going to be talking about what a matrix is, how you read matrices, and how you add and subtract matrices. So basically a matrix is a rectangular array of numbers. So for example here we have matrix Z, and matrix Z would be a 3 by 2 matrix. When you're reading matrices, you always read them rows by columns. You always read them rows by columns. So the reason that matrix Z is a 3 by 2 matrix is because it has 1, 2, 3 rows and 1, 2 columns. So it's a 3 by 2 matrix. And another important part of reading matrices is understanding what an element is. So an element of a matrix is basically just one of these numbers. Like each of these numbers is an element. But the notation for writing an element would be Z, because it's matrix Z, and then there's two numbers down here. So you can have number comma number, it's sometimes written like that, or it'll be Z number number just next to each other. So for example, if we were asked to find Z12, what does Z12 equal? So because we're always reading rows and then columns, we're going to start with the rows. So we're going to go row 1. So we know it's either 3 or 2 immediately because that's row 1. And then column 2. So Z12 is equal to 2. So Z12 equals 2 because we went row 1, right? Row 1. And then column 2. So column 2 because the second number is a 2. So Z12 equals 2. Next we're going to be looking at how to add and subtract matrices. So up here on the top left we can see matrix X and matrix Y. So they're both 2 by 2 matrices because they each have 2 rows and 2 columns. So first we're going to try to add these two matrices together. So when it comes to adding or subtracting matrices, the operation is very simple. So we're going to take element 1, 1 from matrix X, and we're going to add it with element 1, 1 of matrix Y. And so 2 plus 4 equals 6. So now in our third matrix, let's change this, and let's say that X plus Y is equal to Z. So our third matrix, matrix Z, is going to have the element 1, 1, so Z11 is going to be equal to 6, right? Because when we add element 1, 1 of X and element 1, 1 of Y, we get 6. And then we're going to transfer this over to the element 1, 1 of Z, or the top left corner of Z, if that's easier to remember. It's simpler. And then we're going to continue doing that same thing for each of the 3 or 6 other elements. So we add -2 plus -3, which equals -5, and then we're going to place -5 right here because that's the top right equals -5, so we put that in the top right, and then you continue that with these two other. So the matrix Z completed, would be equal to, or would look like this: 6, -5, -2, 14, because 3 plus -5 is -2, and 7 plus 7 is 14. So this is matrix Z. So x plus y equals Z, so x plus y equals this matrix right here. When it comes to subtracting matrices, it's exactly the same. You're just subtracting. So for x minus y equals A, so this is matrix A. A11 equals x11 minus y11. So 2 minus 4, which is equal to -2. So we put -2 right there. And then the operation is the same for all of them. So 2 minus -3, so 2 plus +3 equals 1. So this is 1. And then A21 would be x21, which is 3, minus y21, which is -5. So minus -5, which is the same as plus +5. So that would be 8. So here we have 8. And then finally A22 is x22 minus y22, which is equal to 0. So matrix X minus matrix Y equals matrix A, which is this matrix right here. Okay, next let's try to add matrix @ symbol and matrix pound. So immediately we can see that this is different because matrix @ is a 2 by 2 matrix, and matrix pound symbol is a 1, 2 rows by 1, 2, 3 columns. It's a 2 by 3 matrix. So if you're ever presented a problem where you have to add matrices that have different dimensions, the answer is always undefined. So you cannot add two matrices with different dimensions ever. So the answer is always going to be undefined if they have different dimensions. So here we have an adding and subtracting matrices practice problem. So I recommend that you go and try to complete it on your own, and then I'll go over it. Okay, so matrix A plus matrix B. So we're going to start with the first number in each of the matrices. So A11 plus B11 is 1 plus 3, which is equal to 4. So this is A11 plus B11, which is equal to, we can call the third matrix, or the sum of these two matrices, C, matrix C. So this right here is matrix C. So A11 plus B11 equals C11. So we're going to put 4 right there. And then we're going to continue that operation all the way down. So second number is 2, and the second number is 4. So 2 plus 4 equals 6. And then we're going to come up here and put 6 right here. Oops, it's not a very good 6. 6, perfect. Okay, and then just continue. 3 plus -1 equals 2. And we're going to put 2 right there. And then, so that's the first row completed, right? So we did 1 plus 3, and then we did 2 plus 4, and then we did 3 plus -1. So now we're going to continue down and do 2 plus -2, which is the same as 2 minus 2 equals 0. So we're going to write 0 right here. And then 4 plus 6 equals 10, equals 10. So we're going to put 10, 10 right here. And then finally, we're going to do 7 plus 8 equals 15. Put 15 right here. So this is the answer to A plus B. Okay, next we have matrix B minus matrix A. So we already know what we're doing with we're going to start with B11 and A11. So since it's B minus A, we're going to take B11, which is 3, and subtract A11, which is 1. And that's going to equal 2. So if we're calling this also matrix C, then in this case B11 minus A11 equals C11. So since this is the 1, 1 number right here, we're going to put 2. And then the second one, we have 4 and 2. So we're going to go 4 minus 2 equals 2. Put a 2 right there. And then for the third one, we have negative 1 and 3. So that's negative 4. We're going to put negative 4 right there. And then for this fourth one, bottom left corner, we have negative 2 minus 2, which is also equal to negative 4. And then middle bottom, we have 6 minus 4. So 6 minus 4 is equal to 2. So we're going to put that in the middle bottom. And then bottom right, we have 8 minus 7 equals 1, right? 8 minus 7 equals 1. So we're going to put 1 in the bottom right. And so matrix B minus matrix A is equal to this matrix that we're calling C.